right, let's get started. We are still doing formulas and relationships, functions and relationships. And today we'll be dealing with formulae and tables. Spongogushe is part of the furniture, I knew it. Okay, let's see what we have today. So we are going to complete the following tables and determine the rule for each table. The rule, which is otherwise known as the general formula. We have done this before. In this case, our only difference is that, okay? Our input, instead of Tn, we're gonna have Y. That's our output. And instead of N, if you remember in number patterns, we did Tn equals this and this and this. We have X. Okay, so instead of N, we have X, and instead of Tn, we have Y. So you need to look for the relationship between X and Y, not necessarily the relationship between each of the terms. Okay, so you need to look at this and say, how do I get from X to Y? Does anyone remember how to do this? Does anyone have an idea? Anyone? Anybody? I tried to restart my sharing screen, but I see a lot of people still say their screen is blank, so I'm a little bit nervous. Chichi, let's hear what Chichi has to say.
Hello, ma'am.
Hello.
Ma'am, I just want to try because I also forgot to, but then I think we have to take the previous number, and then we have to calculate it to get to the next number. I think that's how I remember.
Okay, you are suggesting we do cost the differences. Yes, that makes sense. Let's check. But now we have to be careful, Chichi. Remember, when we're doing number patterns, these X's, these inputs would be one after the other. Can you see these are not consecutive? I went from -3 to -1, 0, 1, and then to 3 and 6. I'm busy jumping numbers. So if you're going to do that, just be careful to check that you are checking between terms that are next to each other. Which terms are next to each other? -1, 0, and 1. Do you see that? Those are the three that are right near each other. So that's what we're going to use to check if we have a common difference. So tell me, to go from -1/3 to 0, what am I adding or subtracting?
To go to, hold on.
Okay.
The calculator.
Guys, how do we get from -1/3 to 0? What do we add or subtract? Do we remember?
Oh, -2. Is it not?
No, so you're telling me that -1/3 minus 2 is equal to 0. Is that what you guys are telling me in the chat?
Oh my gosh.
Remember, we find this out by saying T1 minus T0 or T0 minus T -1. So we're going backwards, guys. I need you guys to tell me to go from -3 to 0. How much are we adding? Look carefully. Remember I said we're using our calculators? There we go. Who got it in the chat? Kamugelo. Kamugelo has gotten it. We are adding a third, isn't it? They are inverses of each other, additive inverses. So -1/3 plus 1/3 is how we get to 0. So we are adding a third. And then to get from 0 to 1/3, how much are we adding? How much are we adding to get from 0 to 1/3? Let's see in the chat. We're adding a third again. So tell me, guys, since we're adding the same thing, do we have a constant difference? Yeah, I'm glad when you guys see it. Yes, we do. So we are going to use our constant difference as a multiplier. I know some of you guys might have forgotten this, but some of you weren't here. So what we said was, this number that you keep adding, plus a third. We're going to make this our multiplier. I'm going to explain now what this is. The only thing to remember is you can only use my method if it is a linear sequence, as in if it has a common difference, which we do right now. Common difference means what? We are adding the same thing over and over. So now I'm going to take our multiplier, which is a third, and then I'm going to times it by, let's check with one of these terms. Okay, let's check with one of these terms. I'm going to choose 1. So I'm going to multiply it by 1. Tell me what's a third times 1? Thank you, Charlie. It's a third. Is that the output we are looking for? If I input 1 using the multiplier, I get a third. Is that the output we are looking for? Why are we saying no and yes? Let's hear what people have to say. Kamukelo, what do you have to say? Nope, Kamukelo vanished. Oh, Kamukelo still there. Bali? Is Mbali there? Remember, this is your input, output. I have just inputted 1. Is a third the input that I am looking for? That is my question. The output, excuse me. Oh, there we go. Bali.
Yes.
Yes, it
Ma'am,
is.
good day, ma'am.
Hi. How are you?
Hello. I'm fine, thanks, and you?
Good, thanks.
I can't see anything that you're explaining. Like, how should I do it?
Okay, look carefully, Mbali. We started with finding out what type of number pattern this is, right?
Yes, but the thing is, I can see everyone, but not the board that you're explaining on.
Oh, you're supposed to change views. Please direct message Simone. She'll tell you how to change the view, okay?
Okay, thank you.
You're welcome. Okay. So we have established that that's the output I'm looking for. That means we don't have to add or subtract anything to our sum for it to give us the output we want, because y is equal to a third times x. Now let's test it. Let's test it with, what can we test it with? Let's test it with 3. Let's test it with 3, okay? We said y equals a third times, and instead of x, we're gonna put in 3. Tell me what's a third times 3? What is my answer if you say 1/3 times 3? Thank you, Oyama. The answer is 1. Is that the output we are looking for? Look in the table. When you input 3, do we get an output of 1? Yes, we do. That means our formula is correct. Do we see that? And now we can fill in the rest of the table using the formula that we have just established. Okay, so tell me, for an input of 6, what will my output be? What will my output be if I input 6? Yes, Karabo, you guys are getting it. So if I input 6, I will have y is equal to a third times 6, which will give me 2. So put a 2 there. Okay, and if I input 12, what would my output be? 4. So if you say y is equal to a third times 12, the answer will be 4. So we need 4 over there. Now it's a little bit different, right? So far, we have been substituting the input, but this time they gave us my output. So tell me, in this formula that we have derived over here, this one, where will I substitute my output? Is it where the X is or where the Y is? Where will I substitute my output? My output, look carefully. Is X your input or your output? Hand just went up. Let's hear. Neo. Yes, Neo, do you have a question? Neo.
Ma'am.
There we go.
Hi, ma'am. Ma'am, I don't
Hello.
understand. I'm lost. I'm a bit lost.
Okay, you need to tell me specifically where I lost you.
Everything.
Okay, that's a little bit difficult, but okay. We need to find the general formula of this table, okay? Were you here in our previous lesson?
The one from Tuesday.
Yes.
Yes, I was.
Okay, so you remember, you know how inputs and outputs work, right?
Yes, ma'am.
Wonderful. So let's start all over again. I have a feeling you're not the only one who might be a little bit lost, so let's start all over again. So I gave you a table, right? And I'm asking you to fill in the rest of the numbers that are missing from this table. But for you to do that, you have to find out what formula we are using. Remember previously we used a flow diagram
Yes,
where
ma'am.
it told you you multiply by this and then you add that. So we have to do the same here. We have to find that formula that you use to fill in this table. So if you remember in number patterns, there was a specific kind of number pattern called a linear number pattern. Do you remember that? It's
I'm
an
not sure.
arithmetic or linear number pattern.
No.
So that type of number pattern, okay, or formula like this table is the type where you're adding the same thing over and over, okay?
Yes, ma'am.
But in order for you to know, you need to check. That's why I started here. To go from negative a third to 0, what am I adding? No.
Wait, can you please repeat the question?
To go from negative a third, we're looking at outputs now, okay? To go from negative a third to 0, what am I adding?
2. Negative 2.
From negative 1 over 3 to 0, what is the additive inverse of negative 1 over 3?
Ma'am, I don't know.
It's a third. If you say negative a third plus a third, don't you get 0?
You do.
Do you see what I mean?
Yes, ma'am.
And then to get from 0 to a third, what am I adding?
3.
No. From 0, think of your number line. If you add 0 and you want to get to a third, what are you adding? Think carefully. Check in the chat. They're helping. How do you get from 0 to 2? How much do you add?
Add 2.
Exactly. So to go from 0 to a third, how much would you need to add?
3.
A third. Okay. Do you get it?
Yes, ma'am.
There we go. So since we are adding the same thing over and over, we have concluded that all our outputs are linear. That means we are adding the same thing over and over. So you say plus 1 over 3, plus 1 over 3, plus to get to the next term. Okay.
Yes, ma'am.
Once you have that, you're going to make your plus 1/3 the multiplier. Okay, that means you're going to multiply 1/3 with something. So we want a formula that says y equals 1/3 times x. And then we want to check, do we need to add or subtract anything to get the output we want? Are you with me?
Yes, ma'am.
So now we're going to test it. It's literally trial and error. Let's test it with 1. If my input is 1, where do I substitute 1? Do I substitute it at the x or the y?
The x.
The x. So I'm going to say y equals 1/3 times 1. And how much is 1/3 times 1?
It's 1/3.
It's 1/3. Is that the output we want now? Look at the table.
It's 1.
Is that the output we want?
I don't know, ma'am.
Look at the table. The x's are the inputs and the y's are the outputs. So we inputted 1, right?
Yes.
So we want an output of what's below 1.
1/3.
So that is the output we want, isn't it?
Yes, ma'am.
Look there. So the 1/3 in the table matches with the 1/3 that we just worked out over here. That means we don't need to add anything to this formula. It is perfect the way it is. Okay.
Excuse me,
Yes,
ma'am. Excuse me,
That
ma'am.
means, listen carefully.
Excuse
That means we don't need to add or subtract anything to our formula that we have over here. Are we good?
Yes, ma'am.
So now we're going to use that formula that we just found to fill in the rest of the table. Okay.
Yes, ma'am.
So now we want to fill in under 6 over here. Is 6 our input or our output in the table? Look at 6.
It's our
There
input.
it is. It's our input. So we're going to substitute 6 where?
Ma'am?
Where are we going to plug in 6 on our formula? In the x or the y?
The x.
The x. Okay. So you're going to say y is equal to 1/3 times 6. How much is 1/3 times 6?
Wait, ma'am, I'm still calculating.
Do you have your calculator in front of you?
Yes, ma'am.
Okay. Let's hear. What's 1/3 times 6?
It's 2.
2. Do you see where we got the answers?
Ma'am?
Do you see where we got our answers?
Ma'am, I don't understand that question that you just asked.
Okay, do you understand my explanation now?
Yes, I do.
There we go. That's what I was asking. So then with 12 as well, you say what y is equal to 1/3 this time times 12, because 12 is our input. And then your answer is going to be how much?
4.
4. You see how it works?
Yes, ma'am. Now I do.
And then look at this one. Look at 5 2/3. Is this your input or your output according to your table?
Output.
Output. So instead of substituting that by x, where are we going to substitute it?
By y.
By y. So you're going to say 5 2/3 is equal to 1/3 times x, and then we solve for x. Do you see?
Yes, ma'am.
There we go. I'm glad if you see it now.
Thank you, ma'am.
You're welcome. So then, guys, you're going to say 5 times 3 plus 2. So it's going to be what? 15, 16, 17/3 is equal to 1/3 x. How do we get rid of the third that is on the right? Who knows how to do that? Sibongo kuhle?
Ma'am?
I see your hand is up. Do you have a question?
Now I wanted to help you, but
With
now
which one?
I'm with the following two, but now you're using a different method from the one that I use.
Okay, which one did you use? Let's hear.
So what I said was 5 5 and 2 over 3. Then I said it is divided by 1/3. Is it?
That's
Yeah,
the
that's
same one. You'll see. Okay.
oh okay.
What's your answer? Tell me your
And then
answer. Show you.
No, I thought it was 10.
Okay. How come your answer was 10? Because, okay, 5, 10, 15 plus 2, 17. And then you said we're going to divide both sides by a third, right? That's what you said.
Yes.
So it's going to be 17 over 3 divided by 1 over 3 is equal to x, right?
Yes. Ma'am.
Because we've gotten rid of it on the right. And then we're going to tip and times. If you're using your calculator for this, guys, it's really fine. But it's going to be 17 over 3 times 3 over 1 equals x. And I'm going to get that my x is 17. Has anyone else gotten 17? Or did I make a mistake? There we go. Charlie got 17. Kamkhana got 17. Maybe it's something to do with the calculator. Okay, please check that again.
I'm still getting 10.
Okay, I'm not sure how you're getting 10 because you're supposed to get 7. Do you understand my method that I did here?
I used the same one, ma'am.
Okay. But what's 5 times 3 plus 2? 3 times 5 is 15 plus 2 is 17 over 3, right?
Yes.
And then to get rid of a times a third, you have to divide a third. So you should have gotten 17. It's probably just a calculation error somewhere, okay?
Okay, ma'am. Wait, now I'm getting 17.
Okay, there we go. Now let's do the last one, the one with 8 and a third. Does anyone have an answer for us for 8 and a third? Karabo says 23. Let's check. Let me check up here because I'm running out of space. Okay, I think I can erase this now because I wrote it down. Okay. By the way, if you've been looking at the next question while I've been explaining, it is a special sequence. So think about those special number patterns that we were doing. So it's going to be 8, 16, 25 over 3 times 3 over 1 is equal to x. Therefore, x is 25. If you follow the same steps I did in the previous one, you will get 25. There we go. Beautiful. I think you forgot to add 2, Kamugelo and Karabo. I think you forgot to add 2. There we go. It's okay. It's okay. Now, okay, we're not going to be able to do all of these. Let me remove this one. And let's do this one. Let's do this one. Has anyone checked? Let's check. Does it have a constant difference? Does it have a constant difference? Kamugelo. Let's see what Kamugelo has to say. So we have 14, 11, 8. Yes, Kamugelo?
Excuse me, ma'am.
Mm-hmm.
Well, we are actually lost. We don't know what's happening.
Okay,
we
listen
can't-
carefully with this one, Kamugelo, okay?
Yes, ma'am.
Listen carefully. How do we get from 14 to 11? What do we add or subtract?
14 to 11.
Mm-hmm. To get from 14 to 11, what do we add or minus? They're helping you in the chat.
Ma'am, 40 or 40. Ma'am, you minus 3, right?
Thank you. -3. And then from 11 to 8,
You minus 3 again.
we -3. Do you see we're minusing the same thing over and over?
Yes, ma'am.
So this is going to be our multiplier. We're going to use this thing to be your multiplier, okay?
Mm-hmm.
So,
Are you guys like on some board or you guys see something we can't see because we only see people?
Okay, you're supposed to see a board. That's probably why you're lost. Please DM Simone and she'll be able to help you.
DM who?
Simone,
By the chat, ma'am.
yes.
Okay, what do I type now?
Just tell her that you can't see. She probably knows who you are now, so she'll send you instructions, okay?
Okay, ma'am.
There we go. Okay, if you guys can't see anything except people, you are supposed to see people, okay? Great, so now we're using it as our multiplier. So we're gonna say -3 times x, and we want to see if we need to add or subtract anything to get our output. Now I'm choosing to test my theory with, let's test it with -3. Okay, that's gonna take forever. Let's test it with -1, okay? So if I say -3 times -1, how much is that gonna give me? How much is that going to give me? Eddie. Yes, Eddie.
Hi, ma'am.
Hello, Eddie.
That would give you +3.
+3. Is +3 the output we're looking for?
I
We're
don't
working over
think it is,
here.
ma'am.
When you input -1, you want to get what? What's our output?
Just 8, ma'am.
Just 8, but we just got a 3. So that's not the output we want, right?
Yes.
So what do we have to add to this one to get to where we want? What must I plus to 3 to get to 8?
You must +5, ma'am.
Plus 5, and that's going to give us 8. Therefore, our formula is to be -3 times my input plus 5. Okay, now let's test it using a different input. Let's test it using 3, -3, okay? So if I say
Okay.
y equals -3 times -3 plus 5. What's -3 times -3?
-3 times -3 is 9.
Is 9. And what's 9 plus 5?
That's 14.
14. Is that the output we want? Look in the
Yes,
table.
ma'am.
Yes, it is. So our formula is correct. Do you agree?
Yes.
Yes. So now we know our formula is -3x plus 5. Now let's fill in the rest of the table. I want my output for 0. So where do I substitute 0? In my x or in my y?
In your x, ma'am.
In your x. So it's going to be -3 times 0 plus 5. What's my answer going to be?
Remember, have someone else answer. I have some background noise right now.
Okay, no problem. Okay, thank you in the chat. I see you guys. Paul, there we go. Paul wants to speak to me. Hi, Paul.
Hi, ma'am.
There we go. So what's my answer going to be?
It's going to be 5.
5. Ah, brilliant. Do you want to do another one?
Yes.
Which one would you like to do with me?
Well, I would like to do like number 5, like the input 5.
There we go. And you said it so nicely. The input is 5. So I put it in where you? X or
When
Y?
you X,
X. There we go. Times 5 plus 5. What's -3 times 5 plus 5?
-15 plus 5 is actually -10.
-10. Oh, you're making my night. Do you want to do another one?
Yes.
Let's go for it. I love it. Y equals -3 times 8 plus 5. What's -3 times 8 plus 5?
-24 plus 5 is actually -19.
Beautiful. Okay, you don't have to do the next one with me. Just tell me one thing, okay?
Yeah.
Am I going to plug in my 28 by my X or by my Y?
By your Y.
By my Y. Paul makes me want to dance. Okay. I can't even dance, guys. I'm just embarrassing you guys. So it's going to be negative 28 is equal to negative 3x plus 5. Do you still want to do this one with me, or should I give someone else a chance? Let me see. There are a lot of hands up. Let me give someone else a chance. Thank you.
Yes.
Oh,
You're
that
welcome,
was
ma'am.
brilliant.
Woo.
That was brilliant. Manoko, are you there? No? There we go. Hello.
Hello.
Do you want to do this one with me?
Yes.
No? There we go. Let's do it then. How do I get this x on its own? What do I need to do?
Ma'am.
How do I get this x on its own? Hello? Oh, I just realized my
Hello.
camera is off. Can you help me with this one, or should I pick someone else?
Yes.
Okay, so how do I get x on its own?
I'm not understanding.
Okay, listen carefully, okay? I'm gonna pick someone else and then we'll see how we're gonna do x. Can you see my screen though?
Yes.
Okay, then just listen carefully, okay? I'm gonna ask Oratile to help me with this one. Oratile, are you there?
Hi, ma'am.
Hello, Oratile.
So, ma'am, what I did, ma'am, I said the 28, ma'am, and then I said -5 because, ma'am, additive inverse, ma'am. So then I said -5, and then I got negative 33, and then I divided it by 3, and then I got negative 11.
And that is brilliant, Oratile, you are correct.
Thank you,
Therefore,
ma'am.
x is 11. So our input for negative 28 is 11. Did you do the last one?
Ma'am, I'm still doing it now, ma'am.
Okay, let's do it together. How's that?
Okay, ma'am.
Beautiful. Let me do this. Okay, we're not going to get to this one, I don't think. So let me make more space. Okay, my output this time is negative 37
37.
is equal
ma'am-
to negative 3x plus 5. Let's hear.
Ma'am, doesn't it become negative 3x minus 5?
Remember, the 5 is going over to the other side. So it's going to be negative 37 minus 5. Do you see that?
Yes, ma'am. So then, ma'am, I got negative 42. Then I divided it by 3, and then I got negative 14.
Over negative 3 is equal to negative 3x over negative 3. So x is how much?
Ma'am, I got negative 14.
Are you sure? A negative times a negative gives you what?
Oh,
mind that.
oh, ma'am, sorry, ma'am, I got it wrong. Right.
It's positive 14.
Yes, ma'am,
That's
positive
good.
14.
Boo, boo, boo. Thank you, Ratile. That was brilliant. Thank you for
ma'am.
helping me. 14. Woo! I think that was a lot of work. Okay. Let's see what's going on in the chat before we go on to our brain break. I know my camera keeps turning off. I don't understand what's going on with it. You are not dumb, Oyama. Trust me. I'm going to lower all hands. And then if you have a question, you'll raise your hand. So all hands are lowered right now. If you have a question, raise it. Santrush says, please scroll up to there. Is that fine? Please let me know. Eddie. Yes, Eddie, where did I lose you?
Ma'am, so at the second table, if the last value was like negative 150, would you still use the exact same formula, or would you have to change it by a bit?
Exact same formula.
Okay.
So as long as you have an input, you put it in X. If you have an output, you plug it in Y, but you use the exact same formula, okay? Kuliso,
Hello, ma'am.
hello.
So I want to just ask that if I want to find y, should I use the same method even though it's not the same digit? It's not the same.
If you
Let's
want
say
to find
negative-
Y, then you substitute where we have an X. Look at here. Do you see here where I'm drawing my little bubble?
Yes.
They told us that X is -3, right?
Yes.
So if I want to find out what Y is, then you put -3 where you have X in the formula. Here is our
And then
formula.
I-
Maybe I should highlight it. There's the formula. So if you want Y, you substitute X. But if you want X, you substitute Y.
Y.
There we go. Do you get
I must
it?
say, yes, negative
Beautiful.
3 brackets, negative 28 close brackets plus that digit.
Yes.
Okay, thank you, ma'am.
You're welcome. Wade, let's see what Wade has to ask.
Hey, ma'am.
Hello.
So the formula that you just used now, let's say for the bubble that you do, will you just have to change the numbers and then it'll still give us the correct answer?
Yes, you just have to look at what they gave you and what you want. Okay. Because for instance, here by 0, they gave us 0, right? So you look on your table, 0 corresponds with X, which is your input. So you go put 0 where there is an X. You see?
Okay, ma'am.
And then if they gave you Y, like the ones at the end here, you see here they gave us -28. You go along the table, see -28 is your Y. So you substitute -28 where you see Y. Okay.
Ma'am.
Okay, I hope I answered your question. Kamogelo.
Hello, ma'am.
Hello.
So, ma'am, do you need to do the?
Oh, you're very soft. I can barely hear you.
Do you need to do the calculations to show the calculations?
Do you have to?
Show the calculations.
I would say for that, you must go with the mark allocation. Okay. Sometimes your teacher will just give you a table and say, fill this in. Okay. And then they'll give you like 1, 2, 3, 4, 5 marks. Then you don't have to show the calculations. But if this question is worth like maybe 10 marks, then I would suggest you show calculations. Okay.
Oh, okay.
There we go. Last question. San, is it San?
Hi, ma'am.
Hello.
Ma'am, I don't understand.
Okay, you need to tell me specifically where I lost you.
Ma'am, on the last example we did, from -37 minus 5 equals to -3x.
Oh, the last one. Okay, so look at my table now. They gave us -37. Do you agree? There.
Yes, ma'am.
So you need to check, is my -37 my X or my Y? Is it your X or your Y?
It's our Y.
It's your Y. So then you go to your formula, and where there is a Y, you put -37. Do you understand?
Yes, ma'am.
So that's what we did over here. There. Okay, so we said -37 equals -3x plus 5. Now we want to get rid of all of these numbers around x because we want x to be on its own. Do you agree?
Yes, ma'am.
So you take this 5 and you take it over to the other side because you don't want it to be there. But when it goes to the other side, it becomes a -5. Do you see that?
Yes, ma'am.
So then you say -37 minus 5, and that's going to give you an answer of -42. And then on our right, we're still left with -3x. Are you still with me?
Yes, ma'am.
Great. So now I want to get rid of that -3, right? We still want our x to be on its own.
Yes, ma'am.
So the opposite of timesing is dividing. The inverse of multiplication is division. Okay.
Yes.
So then we divide by 3 to get rid by -3 here to get rid of it. But what you do on the left, you have to go
Do on the right, ma'am.
do on the right. So these -3s will divide into each other. They're gone, right?
Yes, ma'am.
And then a negative divided by a negative gives you
Positive.
positive, and 42 divided by 3 is
Then I
okay. So then what this tells us is if you
yes, ma'am.
input 14, your output will be -37. Do you get it now?
Yes, ma'am.
There we go.
Thank you, ma'am.
You're welcome. And it's time for our brain break. When does 9 plus 5 equals 2? Let's hear. When does 9 plus 5 equals 2? Kuliso, your hand just went up, so I'm guessing you know the answer. Let's hear what Kuliso has to say.
Ma'am, sorry for them. I just want to ask about the last table.
Okay.
What do I actually put to find the value?
You put whatever they gave you. If they gave you the input, then you substitute your input. They gave you the output, then you substitute your outputs. Just remember the X is the input and the Y is your output, okay? Okay, finished. I hope you understand. There we go.
Yes.
So you're fine, you get it now.
Yes.
There we go. Okay, guys, when does 9 plus 5 equals 2? Yes, Eddie?
Ma'am, do you say 9 divided by 5?
You have to add it. Let's think carefully. You specifically have to add it. Let's hear if Oyama knows. Oyama?
Miss, I think it happens when you divide 9 plus 5 equals to 14, then you divide by 7, then it will equal to.
You said something very important. You said 9 plus 5 equals 14, eh?
Yes, then you divide by 7.
Look there. 9 o'clock plus 5 hours is equal to?
14.
2 o'clock. So you cracked it without even knowing.
Oh!
Yeah. So 9 plus 5 is equal to 2 when you're telling the time. Because 9 o'clock plus 5 hours is 2 o'clock. Thank you. You cracked it without knowing.
Thanks, Miss.
You're welcome. Woo! Isn't that funny? Okay. A boy is 2 years old. His brother is half as old as him. When the first boy is 100, how old will the brother be? When the first boy is 100, how old will the brother be? I see 99, 50. Hey, there's a lot going on. Mulimo? Mulimo? Oh, Mulimo's not a meeting. There we go. Hi, Mulimo.
How are you, ma'am?
Good, and you?
I'm good, ma'am.
How old will the brother be? Do you know?
No,
Mulimo, you must know the
I think it's 98 years old.
Oh, you're so close. It's 99.
Oh,
Because if the brother is 2 and this one is half, so 2, half of 2 is 1, isn't it?
oh yes, ma'am.
So the brother's only 1 year older. So if the other one is 100, the other one will be 1 year younger, which is 99. Beautiful. I saw some of you guys got it. Ha ha. Beautiful. That was close. Nice try. Okay. You got it, Tando. I saw that. Okay. 2 mothers and 2 daughters each had 1 egg for breakfast, but they only ate 3 eggs altogether. How is this possible? Oliver's like, I'm done. I'm done. How is this possible, guys? 2 mothers and 2 daughters had 1 egg, but they only had 3 eggs altogether. No, they had 3. How is it possible that they had 3 eggs, guys? Does anybody know? Let me hear someone's voice that I haven't heard today. No voyo.
Hello, ma'am.
Yeah, bo.
Ma'am, is it because one daughter didn't get an egg?
No, they all got an egg. Someone says they shared. Oh, I saw someone in the chat who's very close. Charlie says because there are 3 of them, but how is that possible? Neo, do you have a solution for us?
Yes, ma'am.
Okay,
2 mothers and 2 daughters shared 1 egg.
No, they didn't share. Ho, ho, ho. Guys, it's because it's mother's daughter and granddaughter. Do you get it? So it's the grandmother, it's the mom, and it's the daughter. So there are only 3 of them because it's 2 mothers, she's a mother, and she's a mother, and 2 daughters, she's a daughter, and she's a daughter. That is how there are only 3 of them. Ding, 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 ding. It is like my brain just tapped on. I'm done. Done. Finished it. Yeah. Do you get it, guys? So it's a grandmother, a mom, and a daughter. The mom is a mom, but the mom is also a daughter to the grandma. Okay, let me not. I'm done. Let's do this last one, and then we are going home. I have 3 formulae here. Please match the formulas and tables. Let me number them. Maybe that would be a good idea. Number 1, 2, and 3. Tell me which formula belongs to which table. Let's hear. It was just a brain break. Don't worry. A is number 2. Okay, Carlos seems to already have one of our solutions for us. Kamukalo says A is number 2. What does everyone else say? Guys, the people who are still lost about that thing, think of your mom and your grandma. Your mom is your mom, right? But your mom is also your grandmother's daughter, okay? And your grandmother is a mom. No, it's not a trick question, Chichi. Party B is 3 and A is 2. Let me put these temporarily. So C is 1. Is that what you guys are saying? Is that what you guys are saying? Let's hear what Eddie says. Eddie, have you matched them?
Ma'am, about the brain break.
Yes.
So because it says there's 4 of them, but there's only 2 mothers and
no, it
2
says
daughters
2 mothers
because
and 2
the
daughters.
grandmother's daughter is the other daughter's mother.
Yes. Do you see? So, like, you get it, right, Eddie?
Yes.
Exactly. Good. Chichi wants to ambush me, and I'm not going to allow it to happen. I want to know which one is A, B, and C. Which one is A, which one is B, which one is C? Use substitution, guys. Let's see if Chichi wants to ambush me. Oh, she's gone. She vanished. Spogo Bushle, do you know which one is A, which one is B, which one is C?
No, But ma'am, about the brain break.
Hi guys, you must
I
let the
thought
brain break.
they had an omelet. I mean, it makes sense.
No, it doesn't.
They ate 3 eggs in one.
No, stop it. We are doing the tables now. Come on, guys. I need you guys to answer. You have to go do the quiz. Okay, let's substitute and check. Let's substitute and check. So, a lot of you are saying A is 2, right? So, A says x squared minus 2x. So, if I substitute 0, I'm going to get 0. That is true. If I substitute 2, it's going to be 2 squared minus 2 times 2, which is 4 minus 4, and that's 0. That's correct. So A is 2. What about the other 2? What about the other 2? Anybody figured out the others yet? Anyone figured out the others? B is 1. Let's check. Someone said B is 1 in the chat. Okay, B says y is equal to 2 to the power of 2 times 0, which would be 2 to the power of 0, which is 1. Okay. Okay, yeah, that's probably where you can figure it out. This is supposed to be 1, isn't it? Yeah. And then let's check with a different one. If y is 2 to the power of 2 times 2, which is 4, that is 16, that is correct. So this one is a B, which means the last one is a C. And that concludes our lesson.